All right. Here we are. So, inequality question mark kind of? I don't know. But we have pairwise different positive real numbers such that not only is A2023 an integer, but also so are all the things that led up to it. Fascinating. Okay. Actually, I think these expressions might be annoying enough. I might prefer to use a whiteboard, so let me do that. Yeah, so unfortunately, they happen to be pairwise different, so you can't just set them all equal to 1 and have an equals n. However, an plus 1 is at least, it's like an squared plus some garbage. Like x1 plus dot 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 plus 1 over xn times... Shit, sorry. Wait. Why is it 3034? Really? I feel like it would go up by more than that. So, okay, oh shit, but they're positive reals. Okay. 1 plus... Oh, okay, yeah, I understand. Wait, what am I doing? That's not funny. Okay. Yeah, so like a1 is equal to 1, and then you do the thing where like a2 has to be equal to, because they're unequal, you cannot get equalities, so it's like at least 3. And I'm curious what a3 is. It's like, it's at least 3, but for it to equal 3, you need to have some air gap between the xi's. Like x2 over x1 needs to be, for a2 to actually equal 3, x... one and x2 have to be like a specific ratio. So... Okay, first of all, what's the relation between 2023 and 3034? It's like, it's growing at about 3 halves. So what the problem is asking for a of 2m plus 1 at least what? So 1011, it's like 3m plus 1. And it normally grows by at least 1. Yeah, actually, like, okay. For x1 and for a2 to equal 3, we can, let me write it this way. Like, the ratios have to be a really particular thing, right? Like, a2 equals 3 if and only if x1 over x2 is, like, equal to exactly, oh shit, t squared plus, such that t squared plus 1 over t squared is 7. So it's, like, really far from t equals 2, or t equals 1, which gave 2. Anyways, So A3 is going to be at least 4 just because A2 was at least 3. Just because this thing, the pairwise distinct thing guarantees that something. So I guess the thing is like A4 will be at least 5, but will it be at least 6? And then I have to actually do some calculation. No, wait, hang on. Sorry. Wait, what the hell? Wait, how's the bounce so weak? Wait. No, okay, yeah, that's fine. So I guess because it always increases by at least 1, what I'm hoping is that maybe it's just not possible to get 3 consecutive equal numbers, maybe? So what I would hope, actually, what probably should be equivalent to the problem or so, is that it's not possible to have so I claim that it's impossible to get a of 2n plus 1 because the thing is, when we pick the x n plus 1, we have a bit of leeway, so I don't know. So I claim that this should never happen, is what I'm hoping is true. And in fact, I think this is, given that we can probably get, I don't know. It feels like if this could happen, the problem probably wouldn't be true for like any m. So this is the optimistic claim. I'm not super confident in this, but we can give it a shot and see what happens. This might be a little too optimistic, I don't know. Because if we had this, then what we have is so a3m, if a3m plus 1, sorry, 2m plus 1, should I use 2m minus 1 or something? Oh, let's use minus 1. Minus 1, 2m plus 1. That's like minus 2. Okay, let's see what happens. So am 2m plus 1 was whatever, 2m, which was equal to 3m minus 1. And IMO 5 can go on, like, I don't know. It'll go somewhere. I haven't decided where. Okay, so what you get is that it's equal to 3m minus 2 all squared plus, we'll just call it two new numbers, x and y, okay? We're gonna let let's use p and q actually. Plus 1 and 3m squared is equal to a 2m plus 1 squared. Shiba. There's like a plus p over q plus q over p or something like that. Yeah, I don't know. I feel like my intuition is not very good because the expressions are actually quite algebraic. Also, I am bad at... Hang on. Am I crazy? Is that the right thing? Okay, whatever. We'll just grind for... I don't think I can do very much without actually writing some expressions down because it's so algebraic. So it's like 6m minus 4 and then 6m minus 2 is equal to... Okay, so there's some things I factor. It's like p times the sum of reciprocals plus 1 over p times the sum of the x's. And then this is like p over q plus q over p. This is like q times the sum of the reciprocals plus 1 over q times the... Okay, so then I have to subtract, right, to like actually kill off the m, because I don't really want to do... Do I want to really do... Oh, I don't have enough algebra intuition for this kind of stuff. It feels so weird to not have equality cases that you can debug against. I'm not sure. Yeah, like I can't tell whether I feel like I don't believe the expressions or something. Like 2 is equal to... If I subtract 2 is like this thing that's at least 2, and then something which I am unsure is actually positive or negative. Which is not good. So let me try and remember. How many terms am I expecting? Oh, actually, that's a... I think the thing about like 2m plus 2 to plus 2 is like you need to use the fact that a sub 2m plus 1 is an integer, right? Like, without that condition, I don't think it's going to be true that you could increase by at least by strictly greater than 2, right? Actually, maybe it's still true. No, I don't think it's true. I don't think the bounds are good enough. Because the thing is, you're off the equality case, right? You're not, your intuition that the xi should be about equal is no longer holds. And yeah, however, the algebra is just really, like, overall. Am I getting the... So, the symmetric version is something like 12m minus 6 is equal to p plus q sum 1 over xi plus 1 over p plus 1 over q sum xi plus p over q plus p over q over p. And then... I feel like I need to kill m. Like... Okay, there, I'm just gonna do this. P over q plus q over p plus... oh god, q minus p times... So this is interesting because, like, p equals q is actually an equality here. So I can factor out the shit that is making things negative and get 0 equals, okay, so p minus q squared over pq plus q minus p times 1 over xi plus p minus q over pq times sum xi, and I have no idea what sign I'm expecting to get out of that, but I want to not have minus signs too much. So okay, we'll just factor out the p minus q, okay, and like pray, and maybe something will happen. I don't know. the very legit strategy of like RNG. I don't think this is gonna work. So I feel like I'm kind of running in a circle. Because the problem is it's hard to compare P and Q. Yeah, I don't know. This feels really bad. I might have to actually remember. I was trying to like not remember the past xi's, but I think that's probably a mistake. Because for example, you know, A2 is at least 3. Right. A2 is at least 3, and actually that tells you x1 over x2 plus x2 over x1 is at least a pretty big number, like 7. So I feel like this approach that I'm doing, where I'm just ignoring the past numbers, will not end that well. Like, I'm not using this chunk of stuff. And maybe I need to? I'm not totally sure. But it means like if x1 and x2 differ by a big ratio, like they differ by a factor of at least 7, it means that sums of the form like p over xi plus xi over p will also differ by quite a bit. Right, like if p is oh, is that why it's even? Am I not supposed to? So maybe I do use the m after all. Like if I look at an equation like this, maybe I should trust that this equation might actually... I was trying to do the one that didn't involve m, but maybe that's a mistake. Because the sum has like 2m-ish. Yeah. I don't know. Dude, math is hard. Hmm. Oh god. So we know a2 is at least 3, and if a2 is exactly equal to 3, in fact, then x1 over x2 is such that t squared plus 1 over t squared is 7. Or sorry, t plus 1 over t is 7. Which means like x1, the ratio of x1 against x2 is like at least 6. It's like whatever, it's like 6 and it's very close to 6. It's like 6.7 or 6.8-ish. So that will make it really hard for future numbers to have... Actually, 6 is a really big number. Like, if I have x3, like, what are the... Okay, wait. If I want to make sure that I'm not getting baited, alright? Because there's a chance that I'm getting baited... Oh, no, you need... If you need it to... You need it... Hang on. Yeah, I just feel like the disparity in the xi's is going a lot faster than I can capture with the thing that I'm doing right now. Because I'm not using the fact that like I know that x1 and x2 are really far apart. But what I have right now, I would say the equations that I have are something like these three. So like 12m plus 6 is equal to the sum. So the thing that had the sum in it. Or sorry, 12m minus 6. Yeah. Hello? Whatever. We'll roll that. And then I guess the other... Miro's really not behaving today. But it's like, I want another copy of this equation. And I want to remember the fact that sum xi times sum of whenever xi was equal to... So I feel like this might be enough information remembered. I don't feel like I should be expected to remember literally all the other things that happened. Actually, now that I write it this way, yeah, like x1 over x2. Fucking heck. I wonder if I should just trade the 1 over PQs or something. Like, there's going to be some inequality failure, I think. But I don't know. Okay, there's a really ugly thing I can do where I solve for these two things in terms of P and Q and see if the resulting inequality could plausibly be true in terms of P and Q. That feels super gross, so I'm not sure I want to do that. But it would kind of like... It does feel like this is like what it is. It's like there's... You have some xi's that got up to some numbers. New ones kept getting added, which is fine. And then somehow we ended up here. That just seems so gross. Alright, see ya. Oh, this is... Oh god, this is super annoying. Okay, I'm gonna go back to thinking, like, if we... So if in the world where a2 equals 3, I want to see like what kind of things we're getting. So x2 is like a nice constant such that, like 6.7-ish. And then in order for a3 to hit the minimum value of 4, what I need is like... like 16 should be equal to like 9 plus like 7 point. I'm kind of making up these numbers just as a base reference. Like 1.1 over a3. So a3, sorry, x3 should actually move a bit closer to the center. 6. Wait, how is that even possible? Wait, am I bad at... I'm bad at calculation. See, x3 is about 2, so it's like that one moves a little closer to the center. It's like whatever the square root of... Fuck, I'm not good at this. It's like 2 points, whatever. I'm not sure exactly what. Isn't it 1? Yeah. So like I feel like a4 could plausibly be equal to 5, because for a4 to equal 5, you would need 25 equals 16 plus like 10.7 x4 plus like 1.5-ish over x4 plus 1. 9, 8. Yeah. And then it's like... Wait, no, not 3. Wait, what am I talking about? Sorry, this is like 1 over 2. Oh, that's different. That's like the square root of 7. It's like 2 point... Oh god. Point 3. Okay, so I lied. This is like 8, and this is like... This is a lot bigger than... This is like... 4.2. And the numbers, exact numbers don't really matter. So that will actually be bigger than... Okay. So So actually A4 is at least 6. I don't think you can get A4 equals 5. Which, if true, means that I can work my life is a little easier in that case. What I need is for like the sum of xi and sum of 1 over xi to each be at least. I just feel this calculation is so explicit though. Like. Also, I'm stupid. Hang on. No, something's wrong. Something's definitely wrong. Aren't they supposed to multiply to 16? Didn't I pick a number so they multiply to like 16-ish? So wait, what? Oh god, I'm so bad at arithmetic. Nicky Mohammed follows 3 is 10, 10. Why won't the numbers work out? Is the 16 wrong? Is A3 at least 5? No, that's not. Like, right? Like, these two numbers should multiply to 16. Oh wait, what? Huh? 8 and 4 don't multiply to 16, so what the fuck did I do? Okay, can someone tell me why I'm like dying? Like what oh, I got it that's why. This is 7.7 over x3 plus 1.1 x3. Okay. Okay, that makes a lot more sense. So okay, let me go back to this. Something doesn't sit right now. If I actually, because I got an exact equality here, which wasn't what I was expecting to see. Because for A3 equals 4, if A4 is 25, like the next value, then it's like 16 plus 1 plus 4 plus 4, which actually was exactly the value. So A4 is actually not, or if A4 is equal to 5, then for A4 to equal 5, then something weird had to have happened with somewhere something is more exact than it should be. So now what I want to know is, in this equation, in this first one, I didn't do this at first because I didn't realize this was going to do something, but if I just straight AMGM these, what do I get? It's like 3m minus 2 squared plus two things whose product is actually exactly wait. Huh. Okay, that's fascinating. I'm a stupid head. Wow. Okay, wow. Talk about, okay, not having an equality case really screws with me, huh? If you just straight AFGM though, you actually get like exactly the right thing. So the only way this could actually happen is if like, okay, so screw all this stuff that I wrote here. In order for this to happen, I need exactly the following. Sum xi is equal to, so p times sum xi ought to be equal to 1 over p times sum 1 over xi is equal to 3m minus 2. And sum xi, also same thing for q. Sum 1 over xi has to be exactly equal to 3m minus 1. And also I know that sum xi, sum 1 over xi. So the point is that these equations like are actually, wait, what am I talking about? Yeah. It actually pins down both terms. And we also know that this is true. We assume that sum xi, sum x, the base thingy was 3m minus 2 squared. Why? Yeah, so I think I made a mistake with the indices, because I feel like I didn't realize this until now, but like this is actually, A4 is at least 6. It's actually the even indices that have a better time than the odd ones, I think, if this is doing what I think it is. Anyways, I just want to show that this is not plausible. Wait, why isn't it plausible? Wait, yeah, this is obviously not possible. What am I talking about? It literally, just look at it. It's not true. Like, what am I talking about? Like, it's just obviously not true. Because the product of this thing and this thing is like, wait, I'm so confused. What am I doing exactly? Am I awake? Should I just go sleep? Is there a solution? I don't know anything anymore. Okay, so I think this... Okay, let me just write this up and see if I fail. I hate math. So if I have not completely screwed up, then I think it literally you just can't have 3 consecutive. And this thing I was talking about parity was actually overly precise, and also the thing from before. Yeah. Okay. So it comes down to the following. So note that first of all, an plus 1 is greater than an for all n. Now it suffices to now we claim the main claim is it's impossible to have. Why is text width set to 4? It's impossible to have an equals c, an equals c plus 1, an equals c plus 2 for any, an plus 2 equals for any c and n. Proof. This is so stupid. So first write, so let p equals xn plus 1, and q equals yn plus 1 for brevity. Sorry, xn plus 2 for brevity. There's no way. This is too good to be true, though. Like, Oh yeah, sorry, okay, I fucked up, that's why. Okay. Yeah, I was looking at this and I was like, no, this isn't too nice. The second equation is fucked. I dropped the p and x. I dropped the p plus q and q plus p. And also this is literally like, yeah, it's still 3n minus 2. I think it's still fine because it like, wait, now I'm really confused. What on God's green? Ugh. I'm just gonna write. Alright, well, we're gonna see what happens. Wow, this is so stupid. Then we have, okay, so an plus 1 equals, so the easy case is this, like the one that I didn't screw up, which is equal to sum from 1 to n of xi, sum of 1 over xi, plus p times this thing, plus q times the other one. Sorry, 1 over p times the other thing, plus 1. Let me actually write all these out because I feel like I'm making a lot of mistakes today. So c squared plus things plus 1. Which is greater than or equal to c squared plus like the product of all this junk plus 1. Yeah, so most of the audience is high schoolers for the question in chat. I am not a high schooler, obviously, but also I don't know very much math, so, you know, shrug. So, anyways, equals c squared plus 2 square root c squared plus 1 equals c plus 1 squared. Hence, for equality to hold, we must have exactly some so this thing should exactly equal this thing, which is exactly equal to c. Okay, now when we consider c plus an plus 2, the problem is that if p is actually equal to these things, it's actually too smooth. You know, I'm gonna abbreviate these so that the expressions aren't like a fucking... So an squared equals sn. Also, I'm clowning so hard. I wish t looked a little different because t is like 1 over... Yeah, it's fine. Da-da-da. A plus 2 root st plus 1. Did I get it right? I flipped it, didn't I? T is here. Okay, so this one is actually exactly EP plus Q plus S, and then 1 over P plus 1 over Q. Okay, so, you know, you do AMGM again. And it's like ST plus 2 for the easy terms, and there's like a P of Q plus Q over P. And then there's like S 1 over P plus 1 over Q plus T 1 over Q plus 1 over P. Which I don't... Okay, sorry. No, I shouldn't do it this way. I should do like Q plus P plus S, and then 1 over P plus T. So ST plus 1 plus sorry, p plus s 1 over p plus t plus p plus s times 1 over q plus 1 plus q times 1 over p plus t. Oh my god, algebra. Which is equal to actually exactly c plus 1 squared plus 1 and then plus the cross terms. And the cross terms are plus q over p plus p over q plus s over q plus q over t. And this time by AMGM, it's at least c plus 1 plus two plus 2 times squared st. Okay, is this working? Am I doing the right thing? Is strict because p is not equal to q. To conclude, observe a1 equals 1, a2 So now an plus 1 greater than an together with the above claim are enough to show am 2m plus 1 is at least 3m for all m as desired. S over, it should be s over t, no, probably. Wait, where? No, I think t, it's confusing because like t is the only thing that's degree -1. But I think it is st, the last inequality. No, oh, I see. The problem is that there should be plus q times t. That's the issue. Q times plus q times t. Okay, does that work? Why was I so scared of this? For some reason I thought this wouldn't work. Because I was like, the equality case is wrong, so like it's because it's growing like 3 halves. But that's just not how math works, I think. Like it's the c plus 1, c plus 2. It actually just doesn't matter how big c is. It doesn't, the value of c is irrelevant. When you, because the c squared gets swallowed up and you only care about, oh, okay, so yeah, for some reason I thought c would matter relative to like the sizes of s and t, but they just don't, it just doesn't, so it's like fine. Alright, cool. Alright. Unique holder manip. Yeah, okay, so yeah, I actually overestimated this problem. Unlike the Japanese triangles, which I very much underestimated. Yeah, I should probably sleep, I agree. Oh, what the fuck? Yeah, also the thing that Incomplete said was just correct. Lamau, seriously? You can bypass it all? Yeah, you can bypass it altogether, actually. Oh, I did it in 2 steps. Whatever. I hate math. Wow, today sucked. I mean, this is a proof that an at plus 2 is more like strictly greater than an plus 2, where it squeezes the intermediate, where it's like actually, I mean, it's not really different because like it's I don't know. I just thought the value of C mattered, and it just doesn't because I'm stupid. I mean, these are the same thing. It's just you can get it in one go. I'm gonna. I think for whatever because the value of C doesn't matter. I don't know why I thought it did. In fact, I can clean this up a little bit because like it's like if we repeat the same argument again, then an versus it's like it's actually the same thing. It's like 1 over q plus t. It's like c plus 1. Yeah, actually this is a little cleaner if you do it write it this way. An equals c and an. Okay, that's a lot cleaner. I literally did the same thing twice for no reason. All right. Okay, well, that was that.